The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody, and this is Dr. Mansour. Let me get the screen here for you guys. Let me get the camera. Okay, let me. I think it was on. Here we go. Okay, so today is April the 10th, and this is the second meeting for the FE7, helping those of you who are taking the exam very soon. And I hope that every minute we spend together is beneficial to you. So I emailed you last time the link after I loaded the recording on the Google Drive, and I hope that you get a chance to watch it again if you are interested, and I hope the link is working fine. Let me know if there is any unfortunately, the 9 chapters, the book that I supposed to prepare, I'm still working on it. I'm a little bit busy with too many things. But if we continue doing, or I will continue doing all my best. And I need to jump to the trusses because I invited this is the statics, and I invited the PE group to attend this session today, and they can decide if they would like to stay or not after we finish trusses. It's their choice. So if you look to the NCEES reference, I hope that the audio and video are working fine, and let me know if there is any technical difficulty. So if you look to the FE7, the NCEES reference handbook, which is the only reference that you're going to see on the exam. So the section in the statics portion related to trusses listed under statically determined truss. This is a section of the FE, or the section from the FE. Let me get a question here. One of you is asking a question. Load and clear. Okay, good. Thank you very much. I really appreciate your help and your support. So if you go to the FE reference handbook, the one I showed you last time, and it's available on the NCEES website, you can download the entire book or download only those sections that you really need for the FE7, which already I went over it. So statically determinate truss and plane truss, method of joints and method of sections. So if you look to trusses, those structures that consist of members connected together with frictionless joints, and the smallest truss exists on Earth consists of 3 members. So the basic unit for any truss exists on Earth consists of 3 members, A, B, C, and they have to form a triangle like this. Must be this triangular shape, and we have M as the number of members, and J number of joints, and R are the external reactions. And we're going to see in the section under structure analysis an equation 2J is equal M plus R. If this equation, if the right-hand side equals left-hand side, we call the truss is statically determinate, where we can use the equilibrium equations to solve it. For example, here, how many joints I have? I have 1, 2, 3. Each member is connected with the other member at a joint. So the number of joints here, 2 times 3. How many members? I have AB, BC, and AC, so 3. A plus. How many reactions I have? This is a roller, as all of you know, and this is a hinge. So in this case, at the roller support, as all of us know, we have one reaction, which is C sub Y, and at A, which is a hinge or pin, we have A sub Y and we have A sub X. So if you add the number of reactions, 3, so 6 equals 6. Bingo. So this is a statically determinate. That means that for any given loading, I can find the forces. If I have a load here, excuse me, if I have a load here, P or F is equal to kips, and I know all the dimensions, I will be able to find the forces in all these members. So the 2J equals M plus R. We're going to see this equation in another section, and I discussed it here in my book, that the 2J is equal M plus R is a statically determinate internally. That means that we can find the if 2J less than M plus R is a statically indeterminate internally, and if 2J is greater than M plus R, it is unstable, and the degree of indeterminacy is determined by this equation here, which is a difference between the M plus R minus 2J. So for statically determinate trusses, we need to know how to determine the forces. So our objective from the truss analysis, so trusses, those are the structures that connect all the members together, or connect or consist of members are connected together at joints. Okay, and there are about 6 or 7 assumptions. Nobody will ask you to memorize them, but the major assumptions that if you look to this truss here, you will find that this is A, B, C, D, E, and F, for example. You will find number one, any load, and this is one of the assumptions, all loads will be acting at the joints. Okay? These members, truss members, are axial members. Axial members. What do you mean by axial members? A member that can take either tension or compression. Or sometimes we have something, we call it zero force members. We're going to talk about it. So a tension member, they agreed on the following notations. If I have a member that has two ends like this, one end at each joint, if the member is tension, so the arrows are pulling the joints. The compression, the arrows going into the joints. This is one definition, by the way, with respect to joints. Sometimes we use with respect to members, and I prefer with respect to joints. So if the arrows are pulling the joints, we call it tension. If the arrows are pushing the joint or going into the joint, we call them compression. Zero, obviously, the member has no force, so neither tension nor compression. So the truss problems, like I put on the screen, this is the FE civil practice exam, the one the NCAA has published, and it's giving you a truss. And as you can see, the loads, one load here and another load here at the joint L, joint K, joint J, joint I. He does not have any load at the joint H or in other joints. And he gave you this is 10 kips, 30 kips, 30 kips, 20 kips. And he did something useful, or a gift. I call it a gift. But not necessarily every gift is really a valuable gift. Sometimes gifts can be really valuable, and some gifts just a gift. He found the external reactions for you. So right now we have 10, a plus 30 is 40. 40 plus 30 is 70. 70 plus 20 is 90. Those are acting down. And the 50 plus 50 plus 40 is 90. So we are satisfying the equilibrium equation, sigma force y is equal 0. This is a 2D system. So this is x and this is y. We are not going to talk about trusses in 3D. Okay, it's not required for you. So he gave you the reactions, but I will, and he's looking for the force in the member CD. Where is C and where is D? CD, this member. And he gave you some numerical values. The minus, by the way, that he is putting here to indicate that this is a compression member. I don't know why they put both. Normally we use positive for tension, minus for compression. But if we put compression or tension, there is no need to put plus or minus. But he used both. He used the negative and the compression to indicate that it is a compression member. So member CD is an interior member, not close to the end here, interior, as the members that they are connected to the supports. Sometimes we call them end members or exterior members. But members that far away from this support or this support, as you can see, this support here is a roller support. This is a hinge or pin. And as you can see, the A sub x is equal 0. He did not show that because it is very obvious it is A sub x is equal 0, but the trusses, and what you might see on the exam, it will give you a truss like the one given with some kind of loads, and the loading only at the joint. Okay, so we need to know what we are looking for, what to find. I don't expect that he will ask you for the reactions, because this is for beams. Most likely we find the reactions for beams. But for trusses, we are looking for the magnitude or the force member, or the member force, or the force in the member, and they indicate it is tension or compression. This is one type of questions, like the problem in front of us, problem number 72 is asking how much is the force of this member CD. Okay, and the force in kibs, sometimes they put the units here, and sometimes they put the units here, by the way. And all the loads are kibs, so there is no need to do any conversion or any taking care of the units. So either to find the force in a specific member, and they indicate is tension or compression. Another possible question that you might be asked about is to find the zero force members, zero force, or identify zero force members. Let's word identify zero force. For the FE civil, they have more than the PE, by the way, because we are going to talk later on in the structure analysis. For trusses also, we need to draw the influence lines. So influence lines are required, but this is in another section in the structure analysis. Also, we need to know the deflections or displacement. Here he's asking for the downward vertical displacement in inch for the joint C due to this. So this is a vertical displacement or vertical deflection. Also, this is for the FE and the PE. They are not required to know that. Also, a problem 64. He is giving you a truss, and he's giving you a moving load. This is a moving load. Okay, so he said that a concentrated moves across the truss. So the load is moving, and he would like to know what is the maximum force in the member CD. Because as the load moves across this truss, at one location, this force will be maximum. We need to know that, because when you design a member, I need to know how big this member should be, which is design mean the size of the member, and material, if we go with the material, because the material will affect the size, and connections, and check stability, check slenderness, a lot of things. Design, you must go, you have to get the force first. Because we are going to see, for example, sigma is equal P over A, or F over A in structure and mechanics of materials. In the FE, they call it mechanics of materials, which is a following chapter. I send it to some of you, by the way. Mechanics of materials is a huge chapter. It's coming after that. And we are going to see all these fancy equations, mechanics of materials. Also large number of questions, and we are going to talk about this. So in order to design this member CD, I need to get the force in the member CD. And this sigma is called the stress. And in fact, we are going to use what is known as a sigma allowable stress. allowable stress is equal the force in the member CD divided by the area. I know the force, and if I know sigma allowable, I can get the area. So the area is equal FCD divided by sigma allowable stress. And we are going to see what is this allowable stress later on, where we take the yield stress and divide it by the factor of safety. So the trusses for the FE7 is by far more than what is required for the PE. Here we are talking about moving loads. So you have to know exactly the force in this member. Okay. Its magnitude as this load is. This basically you are going to withdraw something is called, we are going to draw influence line for this member. Influence line is the value of the function or the value of the force. In this case, the function is the force. As a unit load, I'm going to put a unit load here, 1. And I would like to find the force here. And after that, I will put the unit load here and find the force here. And so on, because the loads are acting only at the joint. So I start with a 1 unit load, 1 unit, 1 kib, 1 pound, 1 Newton, name it. It's called unit load. And after that, after I draw the influence line for this member CD, due to a unit load, what will happen if we have 20 kibs? So I am going to place this load at the maximum ordinate, because this is a concentrated load. Concentrated load. For distributed load, we are dealing with area. Sometimes they can give you a load like this, a distributed load, instead of concentrated. So in this case, I still need to draw the influence lines, IL. But instead of dealing with ordinates for concentrated loads, we are going to deal with areas for distributed loads if I know the distributed load. And this will be covered later on. My point is, or what I'm trying to say, is the level of difficulty of truss analysis or the requirements or the knowledge in the FE7 is by far more than the PE. The PE, all what they need to know. If I can show you a problem, we're talking about it, or we talked about it in the past with the PE group. All what they are asking something like this, and we can solve this problem together. Let me see if I can find it. The truss problem. Here it is. This is a PE problem. Okay, this is the PE7 AM. We give a truss, and we have a load of 100 kib here, a load of another 100 kibs here, and another load here. 3 loads, and he's asking a simply supported truss is loaded as shown. The loads in kibs for the members B and C. This member here and this member here. So whatever you learn right now in the FE is going to be very helpful and useful for the PE. It doesn't matter what changes they make in the future for the PE, trusses will still be part of the exam. So going back to how we are going to do that. How can we find the force member? How can identify a zero force member because here in the PE he gave zeros. So maybe one of these members, member B or member C, it might have zero force member or a zero force. So we need to identify that. Reaction is very easy. This is an easy one. For example, here, for this problem number 7, I hope that you order this book, by the way. I don't know if you can download, if it's available or not. You can buy this from the NCEES. I think they sell it, I don't know how much, but I try to get this book because we're going to use this book a lot. This is the study materials. If you go to the website, I believe, if I'm not mistaken, let me see if how much they sell it for right now. It used to be $40 in the past, before Corona. I don't know after Corona what happened. I have no idea. Okay, so maybe they give us discount. Let's go to my website or our website, and I go to the NCEES at the bottom. This is the easiest way for me. Okay, so where is the NCEES? Here it is. I will go here, and this is the NCEES, and I will go the engineering exam materials. Yeah, try to visit this website from time to time about exams. So the FE, here it is, Fundamental of Engineering FE, and a lot of information and exam specifications. Very important to know the exam specifications, because if the, for example, this is the FE Civil, the one we are, it has 14 chapters or 14 sections. What happened? Why is not coming? Please come. Please. I don't know if the internet is one issue from, or here we go. It seems that either I have a problem with my internet, but those are the, for example, today we're talking about statics. Those are the subject, and next week we're going to talk about mechanics of materials and so on. Those are the 14 chapters. The one I told you that the new format of the exam here, it's last one. So if you go back to the exam, where can I find the materials? Study materials, I think. Exam prep materials, here we go. Okay, prep materials, and here we go, here it is. So the FE Civil, FE Civil practice, here we go, that's good. So right now it's $29.95. So it is they reduced by $10. It used to be $39. Review the book now. FE Civil Practice Exam. So so here it is. This is the one I showed to you. Okay. So I try to order this book. I don't know if you can. So they give you a few pages to review. This is another trust problem. We're going to see it, by the way, which is the figure below shows a simple truss. Okay, which members in the truss has no zero force member. So I give you a truss, and they give you some members here. We have answers A and B and C and D. So we're going. This is the one that came last year, July. So this is a review material. He gave it to you, and so try to do your best. If you can get it, order it. That will be a good idea. So the so going back to the chapter that I sent you, okay, 2J is equal M plus R. The three equilibrium equations for any 2D system, as all of you know, the sigma force X, sigma force Y, and sigma moment. I have some brief discussion here about, and I defined the M and J and R here. All loads are assumed to be acting at the joints, as we said. Okay, so the members carrying only tension or compression, like this truss here. Methods of analysis for determinate trusses. they give you only two methods, the method of joints and the method of sections. And I added another method. Normally we cover it in the structure analysis classes, which is basically the cut and sum method. This one here, it came from the method of sections. But I prefer to keep it also as a third method that is available to you. So we have the method of joints and the method of sections. Under method of joints, I told you that two equations only available. Two available equations at any joint, like this joint here. Okay, this is a joint. And this system of forces, we call it, by the way, we call it concurrent force system, because all the line of actions of all forces, they are intersecting at a common point. This is why the NCEES, if you go back again to the NCEES equations, that you will see it on the book. So method of joints, the method consists of solving the forces in the members by writing two equilibrium equations, which sigma force X and sigma force Y. Okay, so the sum forces, I don't know why he didn't put X and Y. He would like to make it general. I have no problem with that. But only, he call it horizontal and vertical. I prefer to use X and Y, but because my grandfather and your grandfather, they agreed this is X and this is Y. And this is 2D. So let us keep our grandfathers happy here. I prefer to put X and Y. He call it horizontal, I will call it X. Vertical, I will call it Y, but that's fine. Okay, so the vertical and the horizontal. So only two equations. Why? Because the method of joints, all the forces are. This is why you will find in my book, I wrote a very good statement and very strong statement. What is this statement? Statement that it's shown on a table. I put these methods in engineers, they like tables. So this is a method of joints. Never pick a joint has more than two unknowns, not two members. Be careful. Two unknowns, not two members. Because I have only two available equations as we just talked. Two equilibrium equations. So if you have a joint has more than two unknowns, you have two equations, you cannot solve it. And again, I put two unknowns, not two members. Okay. Where can we use this? To be used for end or near end members. When you are looking for a force in a member at the ends here or near, maybe this one, I'm thinking about the method of joints. But if this member here, no. If this member here, no. Because method of joints, basically I'm moving from one joint to another. I will finish this joint, come to this joint, and so on. So if you have an interior member, a member that's far away from both ends, the next method, which is the method of sections, which is the most powerful one to handle such. So this is the second method, method of sections. What is method of sections? Method of sections is telling you you are going to cut the truss with an imaginary section. Okay, I will come with a scissor and cut it like this. So this is the original truss or another truss, don't know. I will come here, for example, this section or this 415. If I'm interested to find the force in this member, I will come and cut the truss. Come with a scissor and cut it. Section 1-1. Number one, the section should cut the least number of members. This is one condition. The second condition, you have to cut the member of your interest. Okay, I'm looking for the member CF, so my section has to go through that. After you cut the truss with this imaginary section, now we are going to do what? We are going to take either the right or the left. It's your choice. If you take the right section, I will assume the left does not exist. And I will analyze this. If I decided to take the right section, the left, sorry, I will hide this and I will take the left section to analyze it. And when you take the section, either right or left, you take all the forces internally and externally. Okay? This is one thing I need you to remember from the method of sections. So cut the least number of truss members and cut the member that you are looking for. Because if I cut a member that away or not the member that identified for me, what's benefit for me? As we're going to see in the problem that's given. And so if you go to the table that I generated here, okay, the following table explains the three methods. So the section must cut the member of interest and isolating either side. For example, like this. Here I have three equations. Sigma horizontal, sigma vertical, and sigma moment. Or if you like to call it sigma force horizontal x equals 0, sigma force y equals 0, sigma moment. I try to use horizontal and vertical like the NCEES. So you and remember that the moment equation is very powerful. This equation here, which is the third equation, very powerful. And normally we sum the moment about the point that has the largest number of unknowns. This is when we are talking about an interior member or members far away from both ends. The method of sections is very powerful. Like the problem that we're going to see, this one here. This is far away from either end. If you like to use the method of joints to reach this member, oh my God. And remember how many questions we have? We have 110 questions. And how much time do you have? You have 5.5 hours, 5.5 hours. Is this correct? Yeah, I believe 5. Yeah, 5. So 330. Yeah, over and 110. So you have about 3 minutes per question. The PE, they are happy because they have 6 minutes. Okay? But you have only 3 minutes. So in order to reach this member using method of joints, if I started from either end, I will start from here. This is one, another joint, and I will move here. But be careful. You cannot pick a joint that has more than 2 unknowns. So I will solve about 4 or 5 joints until I reach this member. So if the member is interior, now I will do what? I will come and I will cut it. Section 1.1. And you have the choice. Either consider the left or the right side of the truss. And normally I pick the side that has the least number of loads, because every load will have a role to play in the solution. So this is section 1.1. So method of sections is going back to the chapter. Method of sections is very powerful and we use it a lot, especially if you have, and especially if you give me this truss, tell me, Dr. Mansour, go ahead and use this, analyze this truss for me. So I will give you the solution. You are not going to solve for every single member. You can select specific members to check my work. So we use also the method of sections to check. Or you use a computer program and you enter all the data and you need to check to see if you really entered all the forces correctly or not, all the dimensions are wrong or right. So we use it. So the method of section also is used to check the work, either check a computer printout or to check somebody's work. So to check, okay, work by selecting a few members. I don't have to solve the entire. Okay, the third method, which I told you is not mentioned in the NCEES, is called cut and sum method. This blue box here. The cut and sum method is basically, it came from here, but it is mentioned in the textbook, so I prefer if we can. So an imaginary section, I will answer you in just a minute. One of you is raising the hand. Section may be completely passed through a truss, and after that I apply the horizontal and vertical. So I cut the truss, and after that I sum forces in the X direction and Y direction, or horizontal and vertical. So those are the methods of analysis as far as statically determinate. Be careful. Statically indeterminate, no, we are not going to talk about it here. Statically indeterminate, okay, we cannot solve it. And let me just mention one thing about statically indeterminate. At least you can get what is meant by that. And I will answer. One of you is raising a question, I will answer it. If you look to this truss here, what do you think? Is this a good truss? Is this a truss or not? Number one. I'm looking for something. I found it. I found my toy, the one I got it from Las Cruces in New Mexico, and I was teaching there. Is this a truss? The one you see it in front of you? A, B, C, D. The answer is no. Okay. So this is a toy that I made it way back in Las Cruces, New Mexico, to convince the student that this is not a truss. And why? So let me increase the size here. So this is what you see in front of you. 4 members are connected together. So if there is any load acting on this truss, okay, from this side or vertical or horizontal, what will happen? It will deform. As you can see here, it is. It's not stable. It can do this. Have you ever seen a truss doing this? Or I will be in big trouble if I design a truss like this. Because this is not a truss. This is called a mechanism. In order to make it a truss, I told you the basic unit for any truss exists on Earth. It must be a triangular shape. So in order to make this mechanism into a truss, I have to add another member. Now became a truss. Now, if I added another member, if I have it, but I'm not going to do it, I connect this to this, you will find this became stable. And so it doesn't matter how many forces are acting on this truss, horizontal or vertical, F1, F2, it will be stable. So a truss must consist of triangular shapes, which is, I told you, this basic, and you can add more, you can add more, you can add more. But every time you add, you make sure that you are forming the triangular shape in order, like the truss given in the NCEES. Triangulars, okay, Mem 1, 2, 3. The problem given in the NCEES, in your book, the FE7. triangles. Okay, it must be, otherwise they are not stable. The structure is not stable, and it will collapse, and you will go to jail, or I will go to jail. And okay, how you design a truss? So if you look to the 2J's equal M plus R, in this case, let's look. How many joints? I have 1, 2, 3, and 4. So 2 times 4 equals 2. How many members I have? 1, 2, 3, 4, 5. So I have 5. Plus, how many reactions I have? I have 3. I have the 1, the D sub Y. I have A sub Y and A sub X. So if we add the 3 to the 5, this will give you 8, and 8, bingo. This is a statically determinate and stable structure or stable truss. I can find all the forces on all these members. Okay, so this is aesthetically determined because 2J is equal M plus R. But if I decided to come and add another member, I will add another member from here to here. Okay, but I will not add a joint here. These two members like this, they are crossing each other. The original member, the green one, and the red one, but no joint. So is this statically determinate? No, because right now 2 times how many joints is still 4. How many members right now? M became what? Became 6. 6 plus 3. So this is no longer valid. So this is 9 and this is 8. So in this case, the equation is no longer, okay, and this is aesthetically indeterminate to the first degree. I have 1 extra here, so we need to be, he will not ask you about that. So this is statically indeterminate, okay, and we are not going to talk about it here. So the 3 methods mentioned in the book, and before you analyze any truss, there are 2 important questions I needed to answer. Okay, where are the 2 questions? This is a signed convention. I don't know, probably in the, oh yeah, on the previous page, I skipped it. I will answer you, my friend, one of you. There are 2 important questions I need you to ask before you analyze any truss. Okay, 2 important questions in analyzing plane trusses. Number 1, do we need to find the external reactions at the supports? Not necessarily. Sometimes yes, sometimes no. Which method of analysis should be used to find the unknowns? And in this case, we have 3 methods. They are discussed on the following page in this table form. So 2 questions. I don't like you to jump immediately, okay, to find the external. For example, the problem for the PE. I have here the supports, and here are the loads. Do I need to find the external reactions here? The answer is no. Okay, and this is why I'm telling you that the FE problem 72, he found these reactions, which I'll show you how he got these numbers. Just a refresher, I know you know it. But do we really need them? We will see that. So not necessarily. 2 questions you need to ask yourself if you look to any truss problem. Okay, so the 2 questions I need you to remember. 2 questions. Number 1, do I need, or do we need, the external reactions? Which these reactions, the 50 and 40 and the 0, do I need to find them? And based on your practice and based on experience, you will decide yes or no. And after you answer the first question, you will move to the second one, which is which method of analysis is the appropriate one or is a good one to give me the unknown? So those are the two questions normally I encourage everybody to remember them and to ask yourself before you proceed, because I don't like to jump on the reactions and they turn out, oh, I don't need them. I don't need them at all. Okay? Before I proceed, I believe one of you is raising the hand and asking a question. That's good news. That means that you are awake. Since you are asking a question, okay. Can I get a copy of this? Yes, you will get it. Okay, I will send it to you. No problem. No, the term truss is the term truss and the frame are the same. No, trusses can carry only axial load, but frames, they carry axial and bending and shear. So this member has no moment, carry either axial, either tension or compression. That's it. But if you have a frame, what is a frame? Our friends ask, what's the difference between, or can we assume a truss and the frame? No, are the same? No. A frame consists of beam and columns, like this. This is a frame. Very simple frame. Like buildings are consist of frames. Okay, multi-story structures, either steel or concrete. This is a frame. Basically, I have a beam, I have a column, I have a column, I have a beam. Sometimes we call the beam girder slash beam, but the beam is the most common name for frames. So frames can take bending. So these members, they can take bending like this. They can bend. They can bend like this, a positive and negative bending moment. So we have here, there is no moment. This member cannot take it. It cannot. This why we have something is called, this member here is called, something is called a slenderness ratio. We need to make sure that this member here is going to stay straight, because if it start to sag down like this, it has compression and tension and is not designed for that. So trusses are designed to carry only axial force, okay, like this here. What is axial force? You have a member, okay, perfectly, this is an axial load P, and the cross-sectional area is like this. So this is A, so we are saying sigma is equal P over A. But if the member is designed to carry bending, like beam, a beam, as a cantilever beam, it does have a load. That means it will go down like this, where this is tension and this is compression and this is B. So we have a bending moment. The bending moment, we are going to see it later on, that if this is B times L, and we'll draw bending shear moment diagram. So bending, we have tension and compression. But these members here, either they are axial, carry axial load, only axial, okay? Like a cable, okay? Like a cable, okay? So they don't carry any bending moment, okay? So going back to our discussion here, two questions I need you to remember, that before you analyze any truss, you need to ask yourself, do we really need to find the external reactions or not? And which method is the appropriate method? Okay, so let us solve a couple problems, at least our PE people, because our PE, they have the exam coming very soon on the 22nd of this month, 22nd and 23rd. So pray for them, and also they will pray for you after they pass the PE. They will pray for you to pass the PE too. Okay, so I will skip how can we determine zero force members. It's very, very important to know these two cases. These two cases are listed in structure analysis books. Okay, Hibbler, for example, the latest one, that I used was Hebler, but I still have my books from Las Cruces in New Mexico. And any structure analysis book, you'll find these things are discussed. So it does not make any difference, any book that you are using. So at this sign convention, we need to be aware that this is a tension member. These arrows are pulling the joints. So if this joint AB, so are pulling out. These compression members are pushing, here it is, the arrow going into the joint. Obviously, the zero force members, no arrows are required because they are zero. They are not there, okay? So, let us go to the problem that given in the NCEES book, and we'll see how can we, sorry, I wrote a lot of stuff here, but I hope that you have this book with you. If not, let me go and get another clear copy because I wrote a lot of stuff here and probably will be a little bit. Okay, let me get another. Okay. So if you look to this problem, problem 72, for those of you who have the book, and I will teach it to you as you will enjoy it, and I'm sure that you will like it, and I'm sure that you will be mastering the subject, and I'm sure that you will pass the PE, the FE first, and after that you will shoot for your PE, and you will get your PE, and you are going to make a lot of money, by the way. This is, do you know, this is your check before PE, and this is after PE. You see how big it is? Oh my God. So you see the commercials on the TV before and after. This is before and this is after. You see how big it is? Oh my God. So it's worth it. It's worth the effort and the time and the headache and the stress, whatever you'd like to call it. So this is before and this is after. Okay. Okay. So I'm looking to this problem here. And I need to decide, do I need to find external reactions or not? Oh, he is nice. He gave it to me. But if they are not given, I need you to ask yourself, do I need to find the external reaction? How did he come up with the 40 and 50? Some moment, by the way. So if you sum moment about A, sigma moment about A equals 0, and you clockwise direction is positive, this is optional. So this, I will call this is G sub Y, the unknown to me. I don't know the 4 yet. So I need to find G sub Y. So I say this is 10. He said that this is 6 times 3. I have 1, 2, 3, 4, 5, 6 spaces. So I have 10 times 3, a plus 30 times 6, a plus another 30 times 18, a plus 20 times 1, 2, 3, 4. No, I did a mistake. 3, 6, not 18. This is 9. And 20 times 12. Okay. And finally, all of them are positive because according to this, minus G sub y times the whole distance, which is 18 feet, equals 0. So I can solve for G sub y right now. So G sub y is equal. Just to remind you how to find the external reactions. So it is 10 times 3 is 30. So it is 30 enter, and 30 enter 6 times plus, and 30 enter 9 times and plus, and 20 enter 12 times plus, and 18 divided, so it is 720, 18 divided, I got 40 kips, exactly as he get. Kips, oops, kips. This is how we find the reactions. So you put your finger here, you can start from some moment about G for A sub y, you'll get the same thing. So you can some moment about A to get the G sub y, or you can some moment about G to get A sub y. Obviously, A sub x, this is a bin or a hinge, as you remember. So A sub x is equal 0 because I sum forces in the x direction. So A sub x plus 0 equals 0. So A sub x by inspection is 0. And as you can see here, sigma force y equals 0. And up is positive. So I have 10, 40, 70, 90. So 90 kips going down, minus, this is 40 kips going up, plus 50 kips going up, equals what? It's supposed to equal 0, and in fact, they are balancing. Anything goes down, it should be resisted. Action and reaction. Because if these two are not balancing, the forces or the loads are acting on the truss will start to move around. Have you ever seen a truss moving in a street? No. If this truss, you see it somewhere, please let me know. Okay? So the equilibrium, we are building things, equilibrium. They must be how is EQLIBRIUM, equilibrium. Stability, it must be stable. So it must be stable and it must be equilibrium. It could be equilibrium is not moving around, but it will fail because of stability, and we're going to talk about stability. So this is the thing that I needed to be. Okay, now we need to find the force in this member, the CD. And here he put all of them are compression, by the way. We call this, or call the members on the outside like this, we call it top chord members. Chord members. And all of them are in compression, because the truss is going to deflect like this. This way you'll find the bottom chord members, all of them are in tension. You will find these members here, bottom chord members are in tension. And these are in compression. For these loads, by the way, for this given loading, okay, it depends on the load, but for this given load, and normally these are gravity loads, but all these are loads, these are gravity loads, not lateral loads. Anything coming down, and we're going to see this types of loads, gravity loads, yes, gravity loads and lateral loads. We are going to see the difference between them later on. Let's focus on one thing. So how can I find this? This as an interior member, I have three methods: method of joints, and method of sections, and method of the cut and sum method. So my best choice is the method of joints. I will come and cut it like this. Section AA or section 1-1, whatever you'd like to call it. Method of sections. I need you to remember something very important. The moment I cut a member, the internal force will show up. After I cut the truss with this imaginary cross section, I have a scissor and cut it, I need to decide, do I need to take the right or the left? Or if the truss is vertical, do I need to take the upper portion or the lower portion? Here it does not, you should get the same answer. Okay, but some sections or some sides much easier than the others. And I will tell you why. Let us take the left section, and after that we will see what will happen if I decided to take the right section. And again, this will be learned by practice, because in order to pass this exam and the other exams, as I always say, there are 3 requirements. In order to pass this exam and other exams, you must have 3 things. Number 1, you need to understand the concept very well. Concept. I've been teaching this for a long time, and I always emphasize or stress the concept. You need to understand. Because when you go to the exam, you will not find a problem like this. You will find completely different problem does not exist in any book. But if I understand the concept, it doesn't matter. Number 2, after the concept, I would say I needed to practice. And I would say a million times, practice and the practice and the practice. So name it or repeat after me a million times. Practice. Sky is the limit. Don't say that, okay, do I need 500 hours or do I need 200 hours? Do I need to solve? Keep solving and solving and solving. But understand the concept first, and after that, you need to practice by solving many problems. And I will keep you busy. At the end of each chapter, there will be some additional problems, and I have tons of problems. So after each this chapter, for example, it does have I don't know how many problems, practice problems, we solve it together. 20 something. The last problem I saw was 28. This is 28, and I have some additional problems at the end of the chapter, and okay, and so on. And the same story, this problem, for example, mechanics of materials, probably I was generous a little bit, so I do have problems. I have 34 problems for mechanics, for sample problems. We'll work it together. And at the end of the chapter, I added another, how many? 28. So 28, so 34 and 28. So this is 2 and this is 7. So 72 problems for mechanics of materials only. I believe, this is my belief, if you really understand these 72 problems, understand them not because I said so or because I did it that way. No, I need you to understand why we did it. Because on what if this changed, so we need to. So I believe that you will have enough. Or so concept, practice. Number 3, strategy. As you turn the computer on at the testing site, you have limited time, 3 minutes, we said, per question. In this case, you need to get the maximum benefit of your time. You need to, all the problems are equal weight. Okay? All the problems are equal weight. I don't like to solve the most difficult problem, but it took 10 minutes from me. I will go to my wife. My wife, I solved the most difficult problem today. Oh my God, good, honey. But you spend 10 minutes. You could solve another easy 2 problems and pass. Because it does not make any difference if you are solving the most difficult one or the most easy one or the short one. For example, the last problem in the NCEES, the last problem, if you understand, you could solve it in 22 seconds. Sorry, I'm saying the 22 seconds is, I mean it. Okay, here it is. Problem number 100 is giving you cross-section. It's telling you what is this? This 22-second question. But if you look to some other problems, the truss problem is not bad. You can solve it in 3 minutes. But a beam, okay? Concrete beam. Steel beam. Name it. And influence lines, deflection, here it is. You have to do all this, by the way, these calculations here, all the, he prepared the calculations for you. But you have to do something, and we'll talk about this. So you have to be selective. You have to be selective, and the selection, okay, of the easy problems first, because you can flag question, flag it, and you can go back again. You don't have to answer the questions in order. Okay, the computer will not force you. In fact, you will flag a question, and even before you submit the answers, it will ask you, okay, did you flag? There are some questions are flagged. Are you serious? Are you willing to submit it now? Do you mean it? But I will never leave a single question that unanswered. Even if I have no idea, I will pick one answer and pray to God that may God accept your prayer and you may pass. If God accepts your prayer, but you have to study. Don't say that I will pray for every problem. No, you cannot guess every problem and pray. No, this doesn't work this way. Doesn't work. Yeah, yes, if there is one or two problems and you pray to God, maybe God, but God will not accept your prayer for 110 questions. Will be. So you have to work first and work hard, and after. So my point is that you have to practice and practice and practice. Without practicing, exams are so difficult. The FE, the PE, any exam, even kindergarten. Let me put it that way. Okay. Exams are difficult, and especially the timed exam that you are sitting in front of the computer and the clock is ticking. Clock is ticking, and you have to work like a crazy. Okay. So, and I will help you. I'm not trying to scare you. The people are passing, the engineers are passing. Why? Because they are studying. Some engineers are not, because they are not studying. They just, okay. So right now, we need to go back again to the problem. So I will hide the right hand side. When we take a section, after you cut it, the other section does not exist. And when you take the section under consideration, take it with all forces and all members, and don't forget any. So what I have here right now, I have the following. Let me draw it again here. So I have B is here and C is here. Okay, and I have a member here like this. And I have a support like this at A. And I have A sub Y. He will give it to me as 50 kips. And A sub X is equal 0. Do I have a force here at this joint? Yes, I have 10 kips. I have this joint here, which this is I, and this is K. And I have a member here like this. Okay. And I have another force here is 30 kips. And my section, this imaginary section, it was like this. Here it is. Is this correct? I cut 3 members. I cut the CD, I cut the KD, and I cut the KJ. So I cut this. So this force here in this member is FKG, and the force in this member here is FKD, and this member here is FCD. Because the moment I have this members, or I have the section going through these members, all the internal forces will show up. And don't forget the external forces and reaction. So I took the left side of the truss as one piece. Okay, with all, here it is. Method of sections, we have 3 available equations. Sigma force X equals 0, sigma force Y equals 0, and sigma moment equals 0. I need you to remember that the moment equation is very powerful. Why? Because if I consider this, I have three unknowns. I have this member, and this member, and this member. I am looking for this. This is my goal here. So if I some moment about this point here, which is K, moment by definition, what is moment? Moment is equal force times distance. The force and the distance, we call it arm. Do you remember the arm, the moment arm? So a force going through a point has no moment about it. So if I some moment about K, this joint here, so this FKD will disappear and FKG will disappear. So the only unknown is this force here, because this is known and this is known and the reaction is known. This force along this member is a slanted force like this, because this member, it came from a truss that is this height from here to here is 6. And from here to here is 3, and the 3 and the 3 is 9. I need you to use the horizontal and vertical distances. Or I can simplify this. This is 2 and this is 3. And in this, the hypotenuse is going to be what? 9 plus 4 is the square root of 13. So here, I will say, oh, this here, this is slope 2, 3, and the square root of 13. So this member here has a force FCD. I need to some moment here. The easiest way is to resolve this force into two components, one in the X direction and one in the Y direction. The Y direction has no moment about K also, so the only force that will show up in this one here. This is the FCD in the X direction, and this is the FCD in the Y direction. So I need to some moment about K. So sigma moment about K equals 0. You have to assign clockwise or counterclockwise is up to you. This is an optional. This is not like mechanics of materials. We are going to see it later on. Mechanics of materials, the happy phase and the unhappy phase. Do you remember the happy phase? Happy and unhappy. Okay, let me see if I have it here or not. Mechanics of materials, beam design, we are going to talk about that. Yes, here it is. This is a happy phase. Here it is. This is compression and this is tension. This is tension and this is compression. This is positive bending moment and this is negative bending moment. Agreement. So this is a happy phase after you receive your certificate or the letter first from the NCSS. Congratulations, you passed the FE. So this is compression and this is tension. This is positive. The unhappy phase is like this. And we need to know that. And we're going to talk about that. So assuming tension or compression, this is according to this sign convention. This is standard. Standard sign convention, we cannot change it. But if clockwise or counterclockwise is optional. It is your choice. But the moment you assume one direction, stick with it. Don't change. We cannot change it in the middle. But this is not good. Okay? So in this case, what do you want me to do? Clockwise or counterclockwise? Let me take it clockwise this time, and next time I will take counterclockwise. So I will some moment about here. So the force of the Y, it has, so the FCD in the x direction, which is this component here, which I will calculate it in just a minute, times the arm. How far from here to here? Remember, this is 6. So how much is this one here? And how much is this one here? This distance equal this distance equal this distance. So if this is 6, can I say this is 4 and this is 2 or not? Yes. So this is 4 times 4. So I finished that. Is this a clockwise? Yes, I put my finger here. Assumed, as you can see the arrow I draw it, I assume all the members are tension. So this is assumed to be tension, where the arrow is pulling the joint. And you will find at the end it is negative, by the way. It will end it with the negative sign because my assumption is wrong. But I will assume it tension this much easier, and after that, by inspection, you will know that later on. But so I'm finished with this. After that, this 30 kips will have no moment here. And this member has no moment here. So I still have the 10. So the 10 is negative 10 times 3. And I have the plus 50 times 6. And this is a clockwise. This is all this equals 0. But what is the FCD in the x direction? FCD in the x direction, if you have a force like this is the FCD, and the slope of this line is given 2 horizontal, 2 vertical, and a square root of 13. I can resolve this force into components, one in the x direction and one in the y direction. So the x direction is the FCD divided by the hypotenuse, which is 13, and multiply this by 3. And this is the FCD divided by the hypotenuse multiplied by 2. I needed to know that. This force is gone. Also, when we cover forces, I will tell you there are 2 important rules. Any inclined force or slanted force, resolve it into components. So right now, I have FCDX is FCD divided by square root of 13 times 3, because I'm looking for the horizontal component, and the moment arm, which is times 4, minus 30, which is 10 times 3, okay, a plus 300 equals 0. So now I'm looking for the FCD. So FCD is equal to negative 300, a plus 30, divided by 12, and I'll multiply this by the square root of 30. If I do this simple math, hopefully we'll get a number that's given among the 4 answers and see. So in this case, it is 270 negative divided by 12, and I will take the square root of 13 and times, okay, I got 81 negative 81.1249. This is what I got. 81, and you calculator policy. The NCEES, they have a calculator policy. See if you are using the HB or the TI or whatever, as I told you last time. So this is FCD, and this is in kips. I have 4 answers, A or B or C or D. I found the 81 the closest one, so this is my answer, and I hope this is the answer that given in the solution of this. If not, we can figure out what, but this will be my answer. Can you do all this in 3 minutes? Yes, you can. Okay. Do you remember our President Obama, ex-President Obama, 2 terms? Do you remember Chicago speech, the one, can we win? Yes, we can. Can you pass the FEE? Yes, you can. in order for President Obama to win 2 terms or to serve 2 terms, he was, during the campaign, he was sleeping only, I don't know how many hours. One time I mentioned probably 4 hours or 5 hours a day. And the rest of the time campaigning in order to win. He cannot really win by sitting on the couch at home watching TV. He has to go, and so you need to do the same thing. In order to pass this, you need to give up the couch, the TV, family. No, don't give up the family yet. Okay, just say that, okay, family, I am on a mission, not to Mars. Mars, I believe NASA will take care of that. I am a mission to pass my FE first because I'm looking for the PE in the future. This is the way I will do it, my friend. Okay, this is the way that thrust analysis. Okay, so I need you to remember the 2 questions. Number 1, number 2, the concept is very important to know exactly what you are doing, and I will do all my best to help you to understand the subject and make it easy for you. Let me take a question from one of you. Okay, sorry for keeping you waiting, but I normally wait until the finish the problem, and after that I will be glad to. So the question is, uh, uh, joint L. Okay, did I miss anything? Oh, okay. Yeah. Correcting me. This is HIJKL. Okay, I have no problem with that. My friend is telling me this joint is not joint I joint L. Okay, thank you. Okay, probably I didn't see the L. Yes, you are. Yeah. HIJKL. Okay, no problem. No problem. I need to go back again to the kindergarten. No problem. Thank you. Okay. Shall we take another question before I? No, no questions. Let's go to the break. Okay. So right now is California time is, oh my God, time is flying. Oh, 5:58. Oh, it's 6 o'clock. What happened? Okay. Let's take a few minutes break and come back 10 minutes from now. So 6:10 we'll meet again. Try to take some fresh air. And fresh air, as I always say, that air without corona, please. Okay. Thank you, because I need your safety. Okay. Thank you. Okay, welcome back, everybody. I will try to scan this picture and send it to you, or send this page with my notes. Another area related to trusses, which we talked about it is a zero force member. It is an easy concept, but sometimes they don't cover it in school to the depth that to make it easy. I will try to do my best. So the zero force members, because as you see, or as I indicated, one of the problems in the practice NCEES, one problem is asking, let's see, I think I saw it, I showed you this morning, not this morning, sorry, a few minutes ago, asking the, this is another book. Yeah, so it seems to me, I know it is there. Yeah, here it is. Here it is. I found it. Here it is. Problem number 21. Thank you. So, problem number 21. Why this copy is faded like this? I gave you a truss and is asking which members in the truss has zero force. So, zero force members, and you might say, why they are zero? What's the benefit of these members to be there? They are doing nothing? No. They have a function. They are redundant. We call them redundant members. Redundant. They can take over and carry the load in case of a failure of one of the members. Redundant members. Anyhow, don't forget the design right now. How can we identify or determine the zero force members, or the member they have no force? There are two important rules. They are listed in textbooks, structure analysis textbooks. And this is what I'm presenting, as I mentioned before, to you or to all the classes I'm teaching. I'm not inventing knowledge. Knowledge is in the textbooks. I learn it and I'm teaching it. I'm conveying the knowledge, and that's it. So the knowledge is not an invention by Dr. Mansour or by any other instructor who are representing the material. So two rules. Rule number one. And you don't have to remember rule number one. And they are listed, or they are mentioned in this chapter. Rule number one. Two non-collinear members forming a joint. So I'm saying F, two non-collinear, I believe double L, collinear members forming a joint, and no support or force. Just a minute, please. no joint, no support or force, no support or force at that joint, then these two members are zero force members. Probably the Egyptian English here is not the best English to, or the not the best. But if you look to the chapter, you will find that I put them as rule number 1 and rule number 2 immediately under the table that it has the 3 methods. Zero force members exist according to the following 2 cases, call it rules or cases. Case number 1, if 2 non-collinear members form a truss joint and no external load or support reaction is applied to the joint, the members must be zero force members. Oops, let me get it a little bit clear to you guys. Here it is, sorry. So let me read it again. If 2 non-collinear members form a truss joint and no external load or support reaction is applied to the joint, the members must be zero force members. Translate into English. What do you mean by non-collinear members? Non-collinear members. We are going to see in surveying bearing and distances and all these things. So if this is a member AB and this is another member BC, if these 2 members having this angle to be 180 degrees or they have the same bearing, we call these 2 members collinear. These are collinear. But if I have this member AB and it is just a little bit of C, we call these 2 members non-collinear. So rule number 1 or case number 1, let me call it case number 1 as case 1. So if 2 non-collinear members forming a joint and there is no load or support at that joint, these 2 members will be zero. Like what? Translate into English by giving an example. I have this truss here. Sorry, let me make it nice. And as I said that you don't have to memorize these rules or these cases, just by practicing you will. So I have a truss like this. The basic unit for any truss must be a triangle A, B, C, D, E, and F. And I have a load here. Eight kips. So member CD and member CB, they are non-collinear because they are not having the same line of action. They have an angle, in this case, angle 90 degrees. They are forming a joint, which is joint C. And there is no load over there, and there is no support. So this is a 0, and this is a 0 force member. Because simply, you can take this joint out. Method of joints, we cut the joint and take it outside. So if you take this joint out, joint C, and apply the two equilibrium equations, this is CD, and this is CB. So I have a force here, force in the member CD, and I have a force here, FCB. And there is no any loads or support. So if you apply the sigma force X equals 0, and sigma force Y equals 0, this is 0 and this is 0. You'll end it with 2 0. Are you following me? This member AF also is 0. Why? Because I know the reaction here is vertical. This is F sub Y. This roller here has no horizontal component. So if I take this joint outside as a free body diagram and some forces in the X direction, you will find that this is 0 because there is no any reaction. Here I have two components, A sub Y and A sub X. Maybe some of them will be 0, but they are there. So this is the first rule I need you to remember. Let me read it with you again one more time, and we'll go to the case number 2, because I need to finish an exam tonight I finished it already. I need to review it because the transportation group, they have a class tomorrow, PE class tomorrow, and I need to help them preparing for the exam. And so let me finish the 0 force members, and we'll solve a couple of problems, and we'll stop here, and I will add more hours after we. So case number 2. Case number 2, if 3 members form a truss joint in which 2 of the members are collinear, the third member is a 0 force member, provided no external force or support reaction is applied at that joint. Again, translate into English. Case number 2. Here we are talking about the 3 members. Here it is. 3 members forming a joint. Member AB, AC, AD. 2 of them are collinear. This here, this is collinear. Collinear means the same line of action. Straight line, 180 degrees. And there is no support or load here. This member is 0. The third member must be 0. Like this truss here. Let me make a very quick truss for you guys. This is A, B, C, D, E. And assume that I have only one force acting at the joint B, and this is F is equal 4 kips. And this distance is 4 feet, and this 3 feet, and this 3 feet. So let me this is the truss. I need you to think with me, and I'll give you 2 minutes. How many 0 force members here? Answer A, answer B, answer C, answer D. None, or 2 members, or 1 member, 1, or 2, or 3. And what about this truss? This is also A, B, C, D, and this is E. This is 4 feet also, and this 3 feet here, 3 feet here. And also I will add one load here. F is equal 4 kips. I will give you another 2 minutes. Okay, sorry, my members are straight. Sorry that it seems seems to me that when get tired at the end of the day, so but these members are straight line. Don't say, oh, Dr. Mansour told us the members could be curved like this. No, they are straight lines. These members are perfectly straight. Okay, here we go. I am using a straight edge, so nobody will take me to court. Here we go. So this one here is another example. For this one here, how many zero force members in this truss number 2? Okay. So here, answer A, none. Answer B, 1 member. Answer C, 2 members. Answer D, 3 members. Okay, or let us make it none, 1, 2, 4. What about that? Let's skip 3. So let me give you another minute or so, and we are going to vote. We are a democratic country. We voted, as you know, 2 years ago. Not 2 years ago, last year, yes. Yes, last year, 2020. Time flies, believe me. Or in this case, yeah, the last election. Okay. So for this truss here, the blue truss, let's call it blue, okay? How many members? None. How many zero force members, obviously? None, or 1, or 2, or 3. Okay? Let us vote. We are a democratic country. As I said, that we are going to vote on these trusses to see if you agree or disagree. Okay, 2, 2, 3. Okay, so the blue 2 and the okay. Let us vote on the orange, the blue first. At least at least we can. So let us look here for this blue truss, the blue one. How many? None, or 1, or 2, or 3. Okay, let us hide this right now until we finish the one who vote for the president and the vice president. Oh no, I think they go together, the same ballot, but that's fine. Okay, the blue one, how many? 1, or 2, or 3, or none? Okay, I saw 2 here. I saw 2. Okay. Okay. I need the number first, and after that we'll identify the members. Okay, only few of you vote. I don't know. Voting is legal in this country, as far as I know. You need to vote, my friend. Voting is your right. Don't. Okay. So, if we apply the rule number 1, when we're having 2 members, non-collinear members, members C, B, and C, D are non-collinear. They are forming a joint, and there is no load over there. and no support here. So this is 0 and this is 0. Any other zero force members in this truss? Okay. And you have to tell me why. And if I give you an answer, you have to tell me why. And always ask yourself, who's going to carry the load? Somebody has to take care of these 4 kips, otherwise the truss will start to move around. Okay, let us look to the orange one. How many zero force members in the orange one? Is this orange? Yeah, it's close to orange. Okay, how many of them in the orange one? I need the number. I need the number of zero force members in this orange. I have 1, 2, 4. Okay, I'm still also getting a few voting members. Your driver license is not required. Okay. Okay. Again, we are going to apply some rules here. Members CB and CD are non-collinear members and forming a joint, exactly similar to the previous one. But if you look to case number 2, which is this one here, you have 2 members, member DC and DE, and the third member, this member is 0. I need you to know that by applying rule number 2 or case number 2. 3 members forming a joint, 2 of which are collinear, and no force or no support here, so this is 0. If you come to this joint here, 2 members forming a joint, this is 0 and this is 0. If you come here, since this is 0, this must be 0. Any other 0 non-force members? Any other members, 0 force members? So I have 1, 2, 3, 4, so this is the answer 4. Okay? And sometimes they are tricky, and I'm sure that we are going to work it together, and I'm sure that you will enjoy it. Let me look to the problem that I was referring to in the NCEES, that to see if we are able to get the 0 force members or not. Here it is. This is a problem here. And let me get it closer because it's a light. I don't know if you... Here we go. This is a problem number 21 of the NCEES. And the figure below shows a simple truss. There is only one load here, 4,000 Newton. And this is A, B, C, D, E, F, G. And he is asking which members in the truss have no 0, no force or 0 force member, no force or 0 force member. And he gave you 4 possible answers. And remember, we have 2 cases, case number 1 and case number 2. Case number 2, 3 members. Case number 1, 2 non-collinear members. So if you look to this member BA and BC and BD and BG, sorry. These 3 members are forming a joint, which is joint B. 2 of them are collinear. The 3rd member must be 0. It doesn't matter if this angle 90 or not. Okay, for example, here is not, but if I draw it that way and I draw it that way, 90 is still 0. So the angle not necessarily to be the factor in this case. So I got one member, which is BG. So BG is here and BG is here. And CG, a process of elimination. Already I decided BG is a 0, so it must be answer A or B. I need you to learn the process of elimination. The process of elimination. If I'm able to eliminate 1 or 2 answers, great. So what is left for me? Only 2 answers. If I have only 20 seconds left or 30 seconds, I'll tell you that you have 30 seconds to finish, and I'm able to figure out, oh, this member, so this member is, so either between this and this, and I don't know, I don't have time, I will pick one, 50-50, my friend, and pray to God. Maybe God will accept your prayer. But at least 50-50. Are you following me? If this member is 0, that means this member does not exist, as if it does not exist. So I have 3 members also. There's GC and GF and GA forming a joint at G, and 2 of them are collinear, these 2 members. So this must be 0. CG. And by now, CE is here, CG is here, and B, so that means that the answer must be A. You see? But as far as the CF, what is CF? Here it is, CF. And we have CE. Oh, CE is very easy because I have 2 members collinear, and the 3rd member, this must be 0. So this is 0 and this is 0, as if they don't exist. So I have this member CD and CB and CF, so this is 0. So I have this and this and this and this, and this is the answer A. But by picking a few members, I was able to eliminate some answers, and I needed a process called the process of elimination. And we need to be smart about that, because I needed to save time. If I'm able to figure 1 or 2 members such that I eliminate as many answers as I can proceed. If I'm able to finish all of them, that's good. But if not, if I have limited time and I can narrow my choices to be among 2 answers or 3 answers, instead of 25% or 50-50 is better than 25 each. Make sense? So I needed to be aware of that. So the 0 force members are really, and we are going to practice more. Okay, the more you practice, and I have tons of questions. I have many questions. I can just keep drawing and drawing and drawing, and I can come up, okay, with, okay. So what I needed from you after I scan these things and send it to you, I needed to, these 2 0 force members, the rest of the members exist. They have a force. For example, this member here, BD, what is the force in this member? This member is a compression member, and it has 4 kips. Compression. Why? Because at this joint here, I some forces in the y direction. This 4 kips coming down. Who's supposed to carry it? This member here, BD. Otherwise, again, the truss will move around. No, we don't like any trusses to go out of the street, because it will be dangerous for everybody. So I needed to complete, calculate all the forces, all the members or member forces and indicate T or C. You have to indicate for each one of them is a tension or compression. So the magnitude and the sign either tension or compression. Makes sense? Okay, I will stop here because I need to review the exam I prepared last night for the transportation group. They have the exam coming very soon. I was supposed to send it to them 2 days ago, unfortunately, but they have some issues with computers and files and corrupted. So I will review it and send it to them so they can work on it. And I will have a class tomorrow. So enjoy the rest of your day, and I will scan these things and send it to you. And the lecture also, I'm going to load it after I convert it. I will load it on the Google Drive, and I will give you the link so you can download it or you can watch it, whatever is convenient for you. Enjoy the rest of your day and try to do your best, and I will do all my best. Pray for me to stay healthy. As long as I'm staying healthy, I will keep helping you guys, and as long as you stay healthy, for sure you are going to keep working for the FE. I wish you the best, and bye-bye. Always communicate with me. You can email me, and if there is anything I can help you with, please let me know. I'm extremely busy, but I will do all my best to help you guys as much as I can. Okay? So good night, everybody. Bye-bye.